I'm going to start in the same place as our customers start in, which is typically a monitoring dashboard. And actually, this can be any monitoring dashboard. It doesn't have to be any particular one. And this is where you'll see some really exciting integrations with ScienceLogic coming along. But at the moment, what's being shown are some metrics that were collected from a Kubernetes environment running an online shopping application called SockShop. It's a fairly complex application, has 15 components, all the usual services you'd expect, 80-something log streams, so it's a nice, busy environment. And what you can clearly see in the metrics is around this time, there was some kind of an outage, okay? Now, unfortunately, no matter how much you drill in on these metrics, you will never find out what the root cause is in this case, because the only place the root cause is in the logs. And fortunately, Zebrium is monitoring the logs from this same environment. So I'm just going to scroll down a little bit, and now you see the Zebrium panel. And this is where Zebrium feeds its alerts to when it sees something interesting. And what we see, which is really cool, is just before all the metrics go south on the charts above, Zebrium gets a suggested alert. So we've picked something up in the logs that resembles a problem. And what we do is we throw it back to the monitoring dashboard. You can see it lines up just before the problem, so it's very likely to be related. And without telling you anything more, if you just looked at the words that you see on the screen, you would probably figure out that what caused this problem was Gavin ran a chaos experiment called pod network corruption, which messed with the network, which took out the application for a few minutes. And that is exactly what happened. The only thing is this wasn't contrived in any way. We didn't have any pre-built rules. We didn't have any manual training that went on. We literally just installed a log collector, fed the logs to Zebrium for a couple of hours, and then broke it. So let's have a look at what Zebrium actually pulled out of it. I'm pretty sure you can't read that at the back, so I'll just make it a little bit bigger. So while this was taking place, approximately 2 million log lines were generated from all these different services. So it's a big number of logs just for a few minutes, okay? And certainly a big number for a human to have been watching every single one and said, oh, I think I found a problem. But what we pulled out, and you see it, I'm just going to scroll down on the left-hand side, you see it over here, Zebrium picked up 46 log events out of those millions, spanning 7 or 8 different services that you see listed here on the left where my mouse is, okay? And those log lines are the core of what our IP does. So let's work through those log lines really quickly. Here are the 46 on the right-hand side, and starting at the top, the very first one, and this is really cool, right? It says Chaos Engine initialized. This is where, as I kicked off the chaos experiment, a process went out, the Chaos Engine, and this is where it initialized itself. And then you see a little bit further down, and sorry, let me point out 2 things. So the second column is the severity. So you'll notice that first one, it's not an error, right? It's just one of those boring info level messages that goes unnoticed. And the third column tells you where it came from. In this case, it's one of the Kubernetes events, okay? Now we see in the chaos, the pod network log, just a little bit further, this is where the experiment kicked off. This is where we first see pod network corruption. That's because I ran that particular experiment. So that's the true root cause, right? Gavin ran an experiment called pod network corruption, and that messed with things. But let's look at what really happens beyond that. A few lines further, it looks like a lot more because the font's so big. What we're seeing is, and I'm just having trouble reading my screen over here, and so I've gone a little bit too far. What we see is a kernel log line from the Kubernetes host, from var log messages on the Kubernetes host, that says, caught a queue-length misconfig on ETH0. This is like the technical root cause. This doesn't have a severity. It comes from a completely different place to all those other events. But this is actually where the Linux kernel on the Kubernetes host notices that something's messed up with the network. This is the technical root cause. Now, had I not run a chaos experiment, had this been a genuine kind of network corruption in this environment, it would have started somewhere around here. It would have exhibited itself in this way. So that was picked up. And then we scroll down a little bit further, And remembering the third column tells you where it's from, the second column, now we're seeing the first error. This is now the orders service where it gets a timeout trying to create an order. Okay, so that's where the orders service starts to fail. And on the front end, the website, we get a 500 error. And in the shopping carts service, it gets a socket exception. So these are like the errors the human would have searched for and then had to kind of work backwards against those 80 log streams and 2 million log lines and figure out what happened. So that's what we do. We pick out automatically this sequence of log lines. And I'll just point out, and Larry will talk more about this in detail in a moment, but we also, just to make it easier for human consumption, we try and summarize it. So we have a word cloud that has some interesting words. That's what you saw back in the monitoring dashboard. And we try and generate an English language sentence to describe what happened using NLP. So with that, I'm going to hand it back to Larry Lancaster, our founder and CTO.